This guide will show you how to set up your RFSoC 2x2 board to run Pink, the Python productivity framework from Xilinx Research and the Xilinx University program. The board features a Zinc UltraScale Plus RFSoC ZU28DR, which is a Gen 1 RFSoC device. The chip has 8 ADCs and 8 DACs, and 2 of each of these are available on this board connected to SMAs. You will see how to get the latest Pink image and prepare a bootable micro SD card, set up the board to boot from the card and connect the USB and power cables. You will see the boot sequence so you can tell when the board is ready for you to connect. And once the board is ready, you will see how to connect to the board using the Jupyter Notebook framework and start exploring your board. Your board comes with a micro SD card preloaded with the Pink image, so you can skip this step. However, we recommend that you check for the latest version of the Pink image for your board on the pink.io website and update your SD card if one is available. To write a Pink image to an SD card, first download the zipped Pink image file for your board. You can't copy the image directly to an SD card. Instead, you need to use an application that can format and make a bootable SD card. There are many applications that can be used for doing this. If you're using Windows, we recommend that you use the free program Balena Etcher as shown here. First, unzip the Pink image that you downloaded to get a .img image file. In Balena Etcher, select this image file, then select the target that you will write to. This is your micro SD card. Click Flash to start writing to your card. We recommend that you use a high quality branded SD card and at least 8 GB in size, preferably larger. Faster speed SD cards will be faster to flash and may give you better performance when using your board with Pink. If you are using a Mac or Linux, you can use the dd command to write the image. You can find full instructions for writing the image in the Pink Read the Docs, and you can find a link to this documentation again on the pink.io website. We will use this simplified graphic to show you how to set up your board. Take your micro SD card loaded with the Pink image and insert it into the micro SD slot on the front of the board. Insert the card as indicated. The socket is spring-loaded, so push in the card until you feel it click into place. Locate the boot mode jumper labeled JP1. It is located in the top left area of the board. Make sure the jumper connects pins 1 and 2 to set up the board to boot from the SD card. The RFSoC 2x2 board has a USB 3 composite port. You will connect a USB cable from your computer to the board using this port. When you boot the board with the Pink image, a USB Ethernet gadget will be set up on your computer. This allows you to connect immediately to the board using a web browser. A micro USB 3 cable is included with the board and can be connected to this port. USB 3 is backward compatible, so you can connect a standard micro USB 2 cable to the left part of this port if you misplace your USB 3 cable. USB 3 is faster than 2, although there probably won't be a noticeable difference. If you are using a micro USB 2 cable, make sure to connect it to the composite port for USB gadget and not the other micro USB 2 port on the board, which is for serial port or JTAG. A power adapter is included with your board. Connect it now and always make sure that you are using the right power supply for your board. Once the cables are connected, the SD card inserted, the boot jumper set to SD, move the power switch to the up position to power on the board. Immediately after power on, you should see the power status LEDs on the right side of the board turn on. There are 12 LEDs indicating the status of various power lines on the board. 11 out of the 12 LEDs will turn on. Only the second last LED from bottom, which is for the SysG port, will be off. The power for the SysG port can be configured later and can be changed at runtime. After approximately 40 seconds, the Init LED will turn on, followed by the Done LED. This is a good sign that the system is up and running. The Done LED indicates a bitstream has been downloaded to the programmable logic. A few seconds later, the 4 white user LEDs will turn on and flash several times and stay on. The board is now ready for you to connect to it. You will be connecting to a Jupyter Lab web server which is running on the board. On your computer, open a web browser. The latest versions of Chrome, Firefox and Safari browsers are recommended for use with Jupyter. In your web browser, enter the address 192.168.3.1/lab, and this is the default IP address of the board. The Jupyter password is Xilinx, all lowercase. And you are now ready to start using Pink. In the Jupyter Home area, you can browse to and open some example notebooks already included on the board. You can use these to start exploring your board and learn more about the Pink framework. For further information, go to the link as shown for the RFSoC 2x2 webpage. From here you can find more information on getting started and other resources for your board.